3. Hello. Testing. 1, 2, 3. Okay, so let's fix the camera a little bit. There we go. Okay, today we are going to continue with our Complete Python Developer in 2022 Zero to Mastery course from Udemy. But first, I may like to share. Let's share. I guess I should get into the habit of creating an actual stream schedule. Today, we're going to be learning Python again. But first, let's share to social media. Let's begin sharing in social media first. Okay. This is the 5th study session. I am trying to do this an hour or maybe a little bit more than an hour, and do it every single day. So I want to avoid the issue I had with the gym, doing like 6 hours one day and then never coming back until the end of the year, something like that. Yeah, okay. And Facebook is the last one. I don't really put any attention to Facebook, so I wonder if, well, I guess maybe in the future somebody's going to is going to be willing to see that, I guess. But anyway, okay, looks like all settings are set and I already have everything online. Thank you very much. So let's begin. Okay, just as now that I am already here, why not? Let's update. Let's leave that back there. Let's open. There we go. What? Okay, so I'm watching this one here. Okay, I finish up watching dictionaries. Okay, and let's begin with Developer Fundamentals 3. This is on this study session, I'm going to finish the last videos for this entire chapter or section, may I say. So this was a very big section here. Section 3 is Python basics, which is really useful. This is one of those chapters that I will not skip at all, I guess. Okay, Developer Fundamentals begins here and finish with sets 2. And then tomorrow I'm going to start another big section called Python Basics 2, 3 hours and a half of video, so that's something. But anyway, so let's begin. Oh wait, that's not right. Yeah, I wonder why defaults to that one. There we go.
And this one is understanding data structures. A really good programmer is a programmer that is able to decide what data structure to use when. Up until now, we've learned about dictionaries and lists, and we'll learn about a couple more throughout the course. But a really good programmer, a programmer who's experienced, is able to understand what the trade-offs are, when to use what. And although I can give you a list of this is when you should do this, and this is when you should use maybe dictionaries, the thing is, this takes practice and experience. So throughout our course and then the exercises that we're going to do, the projects we're going to build at the end, I hope that this idea of understanding when to use what data structure makes sense to you. But let's go back to our example. When should you use a list and when should you use a dictionary? Well, the first thing we have to realize that a dictionary is not sorted, right? A list has order. It has 0, 1 indexes, so on and so forth. A dictionary has no order. So maybe if you want to have a list of people in line at your shop, well, you should probably use a list. But maybe you have a user that is playing a game, and that user has first name, maybe weapons, maybe an age. That doesn't have to be ordered, so you might use a dictionary. Also, you'll notice that dictionaries hold more information than lists, right? Because lists only have that single value. That is, a list has the index and then whatever the value is. And here we have a dictionary inside of a list, which is holding a lot of information. Deep down, a list is simply an index and some sort of value here, right? Versus a dictionary that holds a lot more information. It holds a key. So this could be the weapons of that user. Hello can be the greeting of that user. Maybe is magic is another information about that user. So we're able to have both keys and values in a dictionary. So it holds a lot more information.
Yeah.
And as we learn different data structures, you'll have these different pros and cons. You'll start to understand as to when to use what. All right, there's another developer fundamentals. I'll see you in the next one. Bye-bye.
Okay, nice. Dictionary keys.
Welcome back. I mentioned to you that a dictionary's values can
Wait, that was like a refresh. No, just developer fundamentals. It's like a division video then.
hold any sort of data type. But what about the keys? Up until now, I've
Dictionary
only used
keys,
strings
yeah.
to denote a key. But could I do something like this? Could I do 1, 2, 3 like this? Well, let's have a look. Let's give it a try. If I do 1, 2, 3, and I click run, I get 1, 2, 3. Awesome, that works. What about true? If I have a key true and I click run, will that work? Yep, it looks like it works. What about a list? What if I have a list of, let's say, just 100? Would that work? If I click run, nope, it doesn't work. It says unhashable type list. What does that mean? Dictionary keys need to have a special property. A key needs to be immutable. That is, a key cannot change. And numbers, booleans, I mean, this is a value that cannot change. A string, if you remember, is a value that cannot change. It's immutable. But a list, if you remember, can be changed, right? On a list, I can reassign, let's say, the index of 0 to something else, right?
Okay.
So because of that, a dictionary says, hey, my keys, because I'm storing them in memory and I don't want to lose them, it has to be something that isn't going to change on me. Maybe a programmer comes in and by mistake changes this array of 100 to have an index of something else. Well,
Yeah.
dictionary doesn't really want that because it doesn't want to lose this value. So a dictionary key always has to be immutable.
Immutable.
And as we learn a few other things like a tuple that we'll see in upcoming videos, you can use those as keys as well. However, most of the time, 95, 99% of the time, a key for a dictionary is usually something descriptive like a string. Okay, but what about this? What if we have another string, 1, 2, 3, and let's just remove this for now. What happens when I search for 1, 2, 3, the string? If I click run, I get hello. A key in a dictionary has to be unique because there can only be one key because that key is going to represent a bookshelf in that memory space. So anytime I do the same key and maybe add a value, it's going to overwrite. So this no longer exists. A key has to be unique and it's something that can only exist, well, just once. Otherwise we overwrite it, which is why you see hello here. We've lost the array 1, 2, 3. Let's explore this idea a little bit more in the next video.
Okay. Dictionary
Now, if you remember,
methods.
let's have something different here. So we have unique keys. If you remember, we have to have unique keys. So let's say this
Okay.
is greet, and this is a, I don't know, let's say a basket. And we can access basket like this. If I click run, I get 1, 2, 3. But what if we don't know what this dictionary is? Maybe a dictionary is something, well, somewhere else where we can't see. But we want to know if this, let's call this user, if this user has maybe property like age. So do they have this age key?
Find?
Well, if I click run,
No.
I get an error, key error, age. Age doesn't exist. But remember, errors in our programs, and this is something we'll cover later on, are not good. They're going to stop the program as soon as the Python interpreter enters an error.
Yeah, it's
going
an
to kick out of the
exception.
program and say, hey, you have an error, and it's going to completely ignore what's underneath it. Here we don't have anything, but in a real life program, we want to avoid these errors because it stops execution. So another good way to access a key and to see if it even exists is to use .get. And guess what .get is? Did you guess a method? Well, there you go. .get is a method on the object or the dictionary in Python. So here, if we do get age and do run,
Get age.
so my program doesn't error. It just says, hey, there is nothing there.
Oh, it's a method.
We learn what none means by now. So that's a really
Okay.
nice way to avoid those errors. By the way, if, let's say, there's no age in the user, but you want to have a default value, you can do something like this. So you add a comma, and then here, you say whatever you want as the default value. So let's figure that out. If I click run, I get 55. Because now I'm saying, hey, grab the age from the user dictionary. If
That's
age
new for me.
doesn't exist on the user dictionary, use 55. So now we have 55. But if the user already has age, and I click run, I get 20. So this is, hey, in case age doesn't exist, add a default value. That's really, really nice. Now, I'm going to show you another way to create a dictionary, which is not very common. Most of the time, you want to use this syntax. But just so you're aware of it, here's another way. Let's say we have a new user, so user 2. I can create here a dictionary by saying dict, which again is a built-in function.
Okay.
And in here,
It's a
look at that.
built-in
It shows me, hey,
function.
this is going to create a new empty dictionary, and we can create different values,
Okay.
key value pairs. And we simply say, I
Mapping
want the
relationship.
key to equal
Okay.
the value. So in my case, let's just say that I want the name
Uh-huh.
to equal John. If I now print out user 2, well, before I click run, I see that I have a red underline. And by the way, if you see here PyFlakes, that's something called linting, something we'll talk about when we talk about developer environments.
Okay.
We're using this linter that tells you whenever you make errors in Python. And it says keywords can't be an expression. That just means that, hey, the keyword needs to be, well, just a variable.
Variable
So if I click
name.
run here, look at that. I have name John. So we've created a user with this key value pair. Now, like I said, this way of creating dictionaries is not very common. Most of the time, you'll
Yeah, no.
but at least now you know that this is why this built-in function exists.
Okay.
I'll see you in the next one. Bye-bye.
Maybe that's for automated generation, you know. Maybe not a human being is going
By the
to
way,
be
there's actually
creating
one more
that
way that
dictionary.
we've actually seen in lists how to look for an item in a dictionary.
Just give me a moment here. Because I may like to set up. There we go. Ta-da! Okay, let me. I'm setting up Epic Pen for to do this. Okay, nice. Oh wait. But then I may need to wait. Yeah, that may not work as intended. But doesn't matter really. Okay. Yeah, I can work like this. It even looks yeah, I can work like that. Why not? Let's just I'm going to move OBS over here and that should do it. Okay. Ta-da! Okay, let's continue. Another
Remember how in
method.
lists we use the keyword in? We said something along the lines of, hey, is I in a list that contains I? Or we even used a string like hi. Well, you can do the same with dictionaries. I can say, does basket exist in user? And let's print this out.
Yeah.
And run. And it's going to say, yep, basket does exist in user. What about the size? Does that exist?
I get it.
No, that's false.
Yeah.
That does not exist in user. But here is where it gets really interesting. And this, again, is another dictionary method that we can use. And by the way, you can see that there's not that many dictionary methods.
No,
Well,
not many.
Luckily, we're going to go over the main ones here.
Items.
So one is called keys.
Oh, okay.
And keys
It's
simply checks
keys.
the keys. What are the keys of user? So if I go hello here and I click run, well, no, keys are, sorry, on this side, not this. So this is a value.
Oh,
So if I
okay.
want to check keys, I'd say age, which is true. But if I want to check values, well, in that case, if I do hello,
Hello, it's
I
going
get
to
true.
find
It's going
it.
to go over, or what we
Yeah.
call iterate, over the values. Another one that's really useful is the
That's
items.
interesting.
And items is
Okay.
special because we've seen keys and values, but items actually grabs the entire item. So the way we can actually see this is let's just remove and click run. All right, this is interesting. I have
interesting.
dict items here, and I grab looks like a list, and in here we have a bracket basket 1, 2, 3. Greet hello.
Yeah.
page 20. But there's some weird syntax here that we haven't seen before, and this is actually a tuple. So we're gonna hold on to this and talk about this a
tuple,
little
yeah.
bit more when we talk about our next data structure. But keys, values, and items.
During my time working in banks, I use tuples all the time to store records from SQL databases. So basically you recover a data set and you are going to get a lot of rows. And basically I use tuples to create an in-memory storage for the rows once I get them out of the SQL database. So basically I get the row, I get the data, I save it inside the tuple, and I don't save the name of the field because the index of the tuple is going to define that for me. And basically I use tuples for rows. I wonder if there is another implementation or use for them. I wonder.
Is an easy way for us to grab these things for us from our dictionary. Let's continue on with other dictionary methods that we might use. One is a very nice one. It's called clear. And if I run this, you see that I get an empty dictionary. What if I just run users.clear here and run user? Well, it's still an empty object or an empty dictionary. So you can see here that clear doesn't actually return anything. It doesn't, well, it's just in place, removes whatever the dictionary has. So it just creates an empty dictionary. What about copy? Well, a copy allows us to copy a user so that if I print user and user2 and I click run, I get 2 users, each keys and values copied. But if I now, let's say, clear the first user and I click run, the first user is empty, but because I've copied the second user has the old information. And this is a concept that we've talked about before. Another useful command, and let's just go back to having user, is user.pop, which removes a key and a value from the dictionary. So in our case, let's just say we want to remove the key, that is age. So I'm going to say age. And if I run this, I get 20 because pop returns the value of whatever got removed.
Yeah,
If I do print user now, you'll see that age does not exist anymore because we've popped it off.
We
But
pop
pop,
it off.
as you can see, removes the actual value or returns the actual value 20.
Returns.
Here's another really fun one.
So it
Pop
doesn't
item.
disappear.
Honestly,
It doesn't
this
delete
I
it.
haven't used much, but I just think it's a fun one. Pop item, if you guessed, well,
Pop.
you're not going to guess. Oh, and that's because have to make sure I write it properly with lowercase.
Okay.
If I run this,
It pops the
randomly
next
pops up
item
one of the
randomly.
keys and the values. In this case, age 20 is removed. So the last item on the dictionary gets removed. But remember,
Oh,
the
okay.
dictionary is unordered.
Oh, whoa,
So there's
whoa,
a
whoa,
massive
whoa, whoa.
amount-
There we go. No longer random. This function was updated in Python 3.7 to remove the last key value pair that was inserted into the dictionaries. Yeah, I mean, come on. Pop a random item, that doesn't really make too much sense. Yeah, pop item is going to pop the last one. Okay, that makes more sense. It basically gives the functionality of a pile.
massive dictionary that, well, doesn't have any order to it. Sometimes it removes some pair, as you can see, not the last one, but some pair of key value. So
Yeah,
you have to be careful
okay.
with this one. It doesn't necessarily just remove the last thing that you entered, but it might be useful on some occasions. Finally, we have something called update. An update simply updates, as the name suggests, a key value. So simply updates, as the name suggests, a key value. So simply up. Finally,
Useful to destructively iterate over what? A dictionary. Okay.
we have something called update. An update simply updates, as the name suggests, a key value. So let's have a look here. All we have to do is give it a new dictionary, so curly brackets, and just simply say, hey, I want to update age to 55. If I click run, oh, and I forgot a bracket here. Let's try that again. If I click run, there you go. Age got updated. But if this was a key that doesn't exist, like ages, and I click run, it will still update with a new key item. So this is a really useful method. All right, that's it.
Wait. Update ages. Okay, and print the user. So age still exists, but instead of updating something because it didn't find it, it just decides to create it. So this is basically update or create.
For dictionaries, I'll see you in the next video.
Okay. I need to rewatch
Great,
those these short videos later because I'm going to forget about the methods. I'm not taking any notes, but I'm pretty sure that as soon as I start actually when I reach the next chapter, Python Basics 2, not even here. When I reach developer environment and I begin installing, hey, where is Linux? There we go. When I install Python on Linux here, or maybe Windows, who knows, on developer tools, Sublime Text, I guess, customizing, I guess. Well, I'm going to be watching this. Visual Studio Code is here. That's good to see. PyCharm. I did use the one for Java, though. I never used PyCharm because I don't remember if I need to pay for that one, but never mind. I guess that this entire chapter is dedicated to install developer tools to work locally on the computer, because so far I've been writing code inside Replit, which is basically this website here. It's really good because I don't need to install anything, and I can just get directly into learning Python. But eventually I need to install Python. So, and I tried to do so on Windows and failed miserably. So it's going to be, I'd rather wait and see how it's done properly. Okay, tuples.
The third data structure, as we continue down to our different data types in Python. And this one is called a tuple, or tuple, depending on how you like to pronounce it. And we actually saw this slightly when we talked about dictionary.
Yeah, they are immutable.
What are tuples? Well, a tuple are like lists, but unlike lists, we cannot modify them.
Yeah.
They're immutable. So you can think of them as immutable lists. And they look like this. So let's call it my tuple is going to use brackets to denote a tuple. And we can do 1, 2, 3, 4, 5, just like a list. Now, you remember how in a list, we could have modified this and said index of 1, well, now is going to equal z. If I run this, it's going to error out. It's going to tell me, hey, tuple object does not support item assignment. A tuple is immutable. Once you create it, it's the way it is. You can't sort it or reverse it like we saw with lists. It's just, what about this? Can I just print a tuple?
Print a tuple?
And just grab the second item on that tuple?
Maybe.
Well, yes, you can. Just like a list, you can access it through an index. Can I maybe do, does 5 exist?
Yeah, a tuple works pretty much the same as a list. The main difference is that the tuple, once created, is immutable. So whatever change you need to do, you better be prepared to create a new tuple, basically.
In my tuple, just like we could in a list? Well, yes, we can. The difference is that it's immutable, right? Now, why do we need this? I mean, we already have lists, so why do I have to learn tuple if, it's pretty much the same as list? It's the only thing is I can't change it. There's a few benefits to this. For example, if you don't need to change the list, that makes things easier because it tells other programs.
Either you don't need to change it or you don't want other programmers to change it. That's pretty much the issue here. So I use them mainly for storing SQL records, and that's it basically. And I never got an issue with them. Actually, it's a really good thing to do because sometimes, especially if you're working on microservices, you are not really sure what other systems or programmers for that matter, you don't really know how they are going to use your objects basically. So you need to make sure that if you are storing something important like the balance of an account, you may like that to be immutable because you're forcing them to destroy the object and get it again. So it's going to be harder than just assign a new value,
Looking at your code, hey, this shouldn't be changed. Unlike a list, I want this to stay the way it is. Keep this order. So it makes things easier and more efficient. It makes your code safer because people can modify, right? It makes code more predictable. However, it makes code more predictable, but it's
exactly just what I mentioned here.
It's less flexible than a list. I can't really sort a tuple. I can't run reverse on tuple. Now, because of this, because they are less flexible, the other good thing about them is that they're slightly more performant than list. So
yeah, I forgot about that one. They are really fast. And that's what I prefer tuples over lists for large data sets. And I talk in millions of rows. So I did actually realize that during deployment, basically, because somebody asked me how did I manage to read so many rows of data so fast in Python, and I didn't know why. It just is, and that person checked out my code and so, oh, you're using tuples instead of lists, and why is that? And just, well, back in the day when I learned about this, that was the recommendation for storing data from SQL databases, so I did it that way. It was a happy accident.
Faster than lists. And if you don't need a list to change, well, use a tuple. So a good use of a tuple, for example, if you work at Uber, is geographic location and coordinates, right? You can have latitude and longitude here. And because, let's say, this won't change, or maybe a user's location or pickup point doesn't often change, we can just use a tuple. However, maybe when you're in a car as a driver and you're an Uber driver, well, you probably need your coordinates, your latitude, longitude in a list because your car is moving. That's constantly changing. And we saw tuple when we talked about dictionaries, right? Remember when we did user, or we did user.items? And then I said, hey, just print user.items. And we saw here that we got a dictionary items, and inside of this dictionary, we see that basket 123, greet, hello, and age 20 are a tuple. So this actually returns our key and value as a tuple. And as I mentioned before, a dictionary can have keys.
Doesn't return a dictionary.
So a tuple is a completely valid key in Python. So I can do 1, 2 here, and that is a valid key in a dictionary. And the way I would access this would be like user, curly bracket, 1, 2. So that if I click run here, oh, I have an extra bracket. Let's fix that. Let's click run again. And there you go. I'm able to grab user, tuple 1, 2, and grab 1, 2, 3 list. You see here how I'm trying to use different data structures, combining them together.
Yeah.
Let's take a break and finish off our understanding of tuple in the next video.
That was a weird example. I'm going to need to rewatch that one.
Tuples, like I said, are quite similar to lists. So if I
read the notes
tuple,
for that.
Use my tuple and then slice tuple. So for example, if I do 1, 2 like this and print
slicing
tuple, I'm going to get 2, comma. Why is that? Well, we start at 0, 1 and end at 2. If I did 4 here and click run, I get 2, 3, 4. It's still a tuple, but you have to remember that a tuple that only has a single item tends to have this little comma at the end, but it's still a tuple. And just like a list, I can assign different things. For example, I can say x equals to my tuple 0, and then I can say y equals my tuple 1, and x and y will equal 1 and 2. But a short form of doing this, again, similar to lists, is to say, hey, I want x, y, z, and you know what, other, to be the values assigned from the tuple. So that if I do x here and I run, I get 1. If I do z and I run, I get 3. What if I do other? And if I click run, I get 4 and 5 as a list. All right, if your head doesn't hurt by now, don't worry, I have some good news.
Yeah.
Luckily for us, a tuple has only 2 methods that we care about. Count and index. So nice.
Perfect.
Guess what these mean? So let's go back to my tuple and now try these out. If I go my tuple.count, well, it's going to count the value. So if we want to count how many 5s occur in the tuple, I get 1. If I had another 5 in the tuple, I get 2. What about index? What's the index of 5? Well, the index of 5 is 4. Because 0, 1, 2, 3, 4. The first value that it finds, it's going to return the index of. And then finally, we can also do length, right? we can use this built-in function to run length, and it's going to tell us that, yep,
How
it has
many
a length.
how many items are there? Okay.
There it is. We're flying through them now. This is our third data structure. Remember, they're simply lists that are immutable. I'll see you in the next one. Bye-bye.
Nice. Sets. That's a new one. I don't remember
Can you
that
believe it?
one.
I hope I didn't put you to sleep, but we're almost there. We have one last main data type, set, and then we're done. I know this isn't the most exciting topic. Trust me, this is the hardest part. When you're starting out and you're just learning these things without understanding, why do I need this? How am I going to build the next game? How am I going to build the next Netflix? How am I going to build the next coolest Apple app? You're looking at this and thinking, I just learned a bunch of theory. I feel like I'm in math class all over again. I know, trust me, I went through this. I was a self-taught programmer as well. These are the Lego blocks that build our foundation. Once we learn these, we can move on to new things, and you'll see that once you climb this little mountain, things become so much easier. And you'll realize the power when we start building these projects toward the end of the class, where you're going to say, oh, all these blocks that we learned, all this frankly boring part is all going to make sense. So hang in there. It's supposed to be hard. It's supposed to be tough, but you'll see very soon why this is so powerful and why what we just learned is going to allow us to build some really awesome things and create some really awesome programs. So let's finish off with the last one. The last data type, the last data structure that we'll see in Python, at least from the main ones. And it's called set. And sets are simply unordered collections of unique objects. Let's have a look. Let's create a my set. And my set we create with curly brackets like a dictionary, but instead of a dictionary, we don't have key value pairs. Instead, we just have values like 1, 2, 3, 4, 5.
Okay.
That's a set. We just created a set. But remember the definition I gave you. Set is an unordered collection of unique objects. What does that mean? Well, if I print this and say my set, and I click run, I get a set. But if I had, let's say, another 5 in here, and I click run, it only returns the unique sets or unique items. You see, in a set, there's no duplicates. Everything has to be unique. So this 5 just never gets added to a set. For example, you can add things to a set like my set, and then I can say .add and give it a value like 100. And then let's say I do my set.add and then give it 2. If I click run here, I see that I was able to add 100, but 2, well, 2 wasn't really added because my set already contained that data. It's unordered. I mean, we created 1, 2, 3, 4, 5 here, but there's no real order to it. There's no bookshelf in our memory space.
And it doesn't repeat the 5.
These are all over the place in memory, but a set is able to find them because they're all unique. So they're all in just one location in memory. So let me ask you this, and this is going to be a fun little exercise. If I gave you an array.
Wait, let me see this. Okay, that's the dictionary has one a set. It's called a set. Yeah, because it's not a key value pair. It does have curly braces, but it doesn't have key value pairs, just elements. That's the difference. Then you add 100. The thing is that I see 2 5s, but it's only showing 1, which means that maybe one of the 5 is not there anymore. Let me rewind this. Maybe I'm confusing this with actual JavaScript sets, because those work the same way. You may only have one value of one kind there. You cannot repeat on sets. Let me get back here a little bit.
Of unique objects.
Unique objects.
Well, if I print this and say my set, and I click run, I get a set. But if I had, let's say, another 5 in here, and I click
it doesn't
run,
matter.
it only returns the
unique set.
Items.
Yeah.
You see, in a set, there's no duplicates. Everything has to be unique.
Perfect.
This 5 just never gets added to a set.
Pretty much the same as a JavaScript set.
And then I say .add and give it a value like 100.
Okay.
And then let's say I do my set.add and then give it 2. If I click run here, I see that I was able to add 100, but 2 wasn't really added because my set already contained that data. It's unordered. I mean, we created 1, 2, 3, 4, 5 here, but there's no real order to it. There's no bookshelf in our memory space that is right next to each other. These are all over the place in memory, but a set is able to find them because they're all unique. So they're all in just one location in memory. So let me ask you this, and this is going to be a fun little exercise. If I gave you an array, and let's say this array contained, well, this right here.
A list.
And I want you to return an array with no duplicates. So I want everything in, let's call it my list.
My list.
And a programmer has already created this. Okay? And then your task is to create or return a list or a collection that has only unique items. How would you go about converting this into a set? Well, we've seen this before. We have a set function, and we simply wrap my list in that set.
Oh.
And let's print it out.
And that's it.
Check it out. We have formed a new set from a list.
It returns
values. When would this be useful? Imagine we had usernames, right? Or email addresses. We're collecting email addresses on our startup page. But we don't want to have duplicate emails. We might want to convert this, a list of emails, to a set and remove any duplicates, so we're not sending emails over and over. So that's really cool.
Yeah.
What about this? Let's change this into a set. So let's call it my set. I'm going to change this into a set. There you go. And then what if I wanted to access my set at index of 0? Set object does not support indexing. Well, again, you can think of it more as a dictionary. In order to access a set, we have to grab by the item that's in it. That's the key to getting the information from memory.
Oh,
the way we would check if something exists is we simply say, hey, is 1 in my set? And we run
as
this,
an index.
and we get true. We can also do length of my set, and we get 5. Again,
okay.
nothing too crazy, but 1, 2, 3, 4, 5. Remember, it only counts the unique things because this will never get entered. It's a set. And alternatively, we can also convert this into a list. If I click run here, you'll see that I now have my set as a list. And then we can also do, let's say, my set.copy, and actually copy my set into something, let's say, new, or new set. And then this will be completely different.
I wonder if sets are mutable.
So let's test
I think they do because
set,
I saw him.
a method that we may have seen before, which is my set.clear, which, as you can imagine, clears the set.
Yeah, it's mutable. Okay.
I have that new set, but when I try and print our old set, which was my set, it's going to be empty, an empty set.
Okay.
But the true power of sets comes in the next couple of methods that I'm going to show you. And sets have quite a few methods, but don't worry. Most of them are quite similar. So let's explore that in the next video.
Okay. The methods for the sets, and that's it, basically.
Welcome back. The methods we're going to talk about when it comes to sets are right here. It looks like a lot, but they're quite similar, so hang in there. I have 2 sets for us. Our my set, which is 1 through 5, and then your set, which is 4 through 10.
Okay.
Now, let's go one by one and see what these methods do. And if you've ever seen Venn diagrams in your school, for example, 2 circles that are overlapping each other, what we're about to do is quite similar to this. The first one is difference. And sets are very useful when having 2 sets and comparing them to each other. So for example, in here, difference simply says my set dot difference, and we give it another set, such as your set. If I print this right here, and I click run, I get 1, 2, 3. It's going to find the difference of the first, my set, with your set. So any duplicates between the 2, which is 4 and 5, gets ignored, and it only shows the difference, that is 1, 2, 3. What's different between my set and your set when viewed from my set? Well, your set doesn't have 1, 2, 3. What about the next one? Discard. Again, if we do my set dot discard, it says it removes an element from a set if it is a member. So here we can say discard 5. And if I do print my set and I click run, I get none. But if I print here my set and I click run, I get 1, 2, 3, 4 because we've just discarded 5. It modifies our set. Just to keep our working space clean, I'm going to comment these out. Next is difference update. So I'm going to say my set, and then once again, let's see what difference update does. Remove all elements of another set from this set. So if I do your set here, and once again, I do print, and I click run, I get none because it just modifies my set. So remember, we just have to have our print, my set, and now this my set is updated with just 1, 2, and 3 because we're updating it so that the differences are removed. So 4 and 5 are removed. Unlike the difference, where it just told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here, but then my set bottom was modified because of difference update. Right, a few more to go. Intersection.
Let's
and this one, once again,
that part.
Set from this set. So if I do,
actually it starts here.
I get 1, 2, 3. It's going to find the difference of the first, my set, with your set. So any duplicates between the 2, which is 4 and 5,
is it nor?
Gets ignored, and it only shows the difference, that is 1, 2, 3. What's different between my set and your set when viewed from my set? Well, your set doesn't have 1, 2, 3. What about the next one? Discard. Again, if we do my set dot discard, it says it removes an element from a set if it is a member. So here we can say discard 5. And if I do print my set, and I click run, I get none. But if I print here my set, and I click run, I get 1, 2, 3, 4 because we just discarded 5. It modifies our set. Just to keep our working space clean, I'm going to comment these out. Next is difference update. So I'm going to say my set, and then once again, let's see what difference update does. Remove all elements of another set from this set.
Oh,
so
okay,
if I do your set here, and once again, I do print, and I click run, I get none because it just modifies my set. So remember, we just have to have our print, my set. And now this my set is updated with just 1, 2, and 3 because we're updating it so that the differences are removed. So 4 and 5 are removed. Unlike the difference, where it just told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here. And my set bottom was modified because of difference update. Right, a few more to go. Intersection.
So
and this one, once again, my set. And find the difference, find the difference of the first my set with your set. So any space clean, I'm going to told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here. But then my set bottom was modified because of difference update.
So basically, whatever is different between these two, between this line, it's going to be easier with this. So whatever is different between this and this, which is basically these two values here, these two values are going to be removed, and I only going to get whatever is they have in common, whatever they have in common, which is basically this value here. That's what is going to be printed down here. that's what difference update means. Okay. I guess if I'm comparing two datasets, that's going to be useful.
Right, a few more to go. Intersection. And this one, once again, my set. And in here, once again, let's read what it does. It just
The
has
contrary.
intersection with something else. Well, let's find out. If I do your
Okay.
set here, and I do print, and I run this, it's going to give me 4, 5, because
4,
that's the
5.
intersection, the two common things that my set and your set has.
The two common
about this-
things that
this
we
joint?
have
Well, if I do my set, and then your set,
is
I feel like I'm
joint.
saying those words over and over. Hopefully that's not too annoying. And then here, if, let's comment this out, we run this, I get false. If this joint simply says, hey, are those two circles overlapping? Do they have anything in common? If, for example, my set didn't have 4 and 5, and I click run,
Yeah, it does.
I get true, because it's disjointed means these sets have nothing in common.
Disjoint.
Awesome.
Okay.
Just a few more. The next ones we're going to see is subset and is superset. But actually,
Okay.
before we do that, let's do union.
Union.
see what this does.
Okay.
Union will say my set,
It's going
and in here,
to
we want to
join them.
the other set, your set. If we print
Okay.
this and click run, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
It's going to
That
join
just did?
them.
Well, union just united these
Unite.
sets together, but removed any duplicates. That's kind of nice.
Remove duplicates.
And as you can see,
Great,
it created
actually.
a new set for us. It returned a new set.
It returns
By
a
the way,
new
there's
set.
actually a shorthand that
Okay.
you can do here in Python, which is the shift and then the key above your enter, which is right here, this straight line. So shift and then the backslash, but if you press shift, you'll get this little straight line. If you print this,
Okay.
well, remove the brackets here. Let's run again. And you see that works as well. And by the way, this also
Okay.
exists for intersection. Again, you don't see it that often, but with intersection, you can do the same thing where you just do the and. if you do that-
Intersection, like and.
It gives you the intersection of my set and your set.
Okay.
All right, I promise you this is going to be short, so 2 other ones. Is subset and is superset. As you can imagine, my set, if let's say my set only has 4 and 5, and I say, hey, is my set, is that a subset of your set? And I print this, if I click run, it's true. My set is a subset. That is, it's inside of the circle of your set.
inside
Because 4 and 5
your
is
set.
inside of it. So my set, the entirety of my set is inside of this other set, which we call a subset.
Okay.
On the other hand, we also have this idea of superset. So if I do instead of is subset, is superset, I'll get false because, well, my set is not a superset. It doesn't encompass your set. It's the other way around. Your set is a superset of my set. Because your set encompasses everything that my set has, which is 4 and 5.
Okay.
Oh boy, that was a lot. And you're asking
Yeah.
yourself, there's no way I'm going to memorize any of that.
Nah.
I don't memorize
I'm
any
going
of
to
this.
forget
As a
tomorrow.
matter of fact, I
Yeah.
usually go to the Python documentation or just Google around. And because I know sets exist, if I ever want to compare, let's say, 2 sets, I know to just go here and find the tool that I want. That's the key
Find
programmer
the
that I keep mentioning over and over.
difference
It's not
between
memorization. It's the ability to know that
difference
there's tools that you
between
can use
two
and being able to
sets, okay.
Google for them. I know it doesn't sound exciting because in movies you see everybody typing super fast and coding everything, but
Nah, that's a lie.
real
That's
life,
not real life.
Google
Yeah.
around, find solutions because by now you know what sets are, you know what sets can do, so that you can Google for methods that are appropriate to your
You
problem.
just look for
Also
the
nice.
methods or the functions. That's true. Yeah. Very generic. Okay, so let's see. We already it's early, but I already finished this one. Okay. There is an exercise on Ripple. Let's see the exercise. Let's see what about it. Okay, what should I do here? Set methods. That's another link. Ah, okay. I don't see any instructions or any mention of this one. Okay, I see some code on the comments. I don't know what this does. Show files, I guess. Okay. It reads, let's make it a little bigger. It reads, scroll to the bottom to see solution. You are working for the school principal. We have a database of school students. Bobby, Tammy, Yami, Sally, Danny. Okay. During class, the teachers take attendance and compile it into a list. Attendance list. Yami, Bobby, Danny, Sally. Okay. Using what you learned about sets, create a piece of code that the school principal can use to immediately find out who missed class. Okay, so they can call the parents. Imagine if the list had 1,000 of the students. The principal can use the list generated by the teachers plus the school database to use Python and make her job easier. Find the students that missed the class. Okay. This one get used to immediately find out who missed class. Okay, so if this is the school list and this is the attendance list, and I do have a list here, and this is a set. So the top one is a set, the bottom one is a list. So what I may like to do here is finding the difference, and I want to know who is who was missing class basically. Okay. Okay. So I wonder how can I type here? I'm not able to type. Maybe I can just copy all this and paste it here. There we go. A skip class, I want to call this variable. And I need a method that I may apply either on a school. Let's see, Python methods, set methods, there we go. So I'm supposed to apply this on a set. Okay, set replet. Okay. A skip class is going to be equals to a school. And I wonder if I had methods here directly. No, maybe here. I want to find the difference. Returns a set containing the difference between two or more sets. It needs to be a set. I wonder if intersection returns a set that is the intersection of two or more sets, and returns whether two sets have intersection or not. Okay, I'm going to find the difference then. Returns, let's see, examples maybe. It's pretty much this. Seed is X difference Y. Okay, try it. There we go. So that's the difference. Apple, banana, cherry, Google, Microsoft, Apple. So Apple, okay, the difference. Okay, so whatever is different. So Apple appears on both. Okay. So maybe this is the thing I need to do. It's basically a dot, and I pass the set as an argument. Okay. Let's try it out. And attendance list. Can I just copy? And just print skip. I wonder if I do have a, oh wait. Do I have a, okay, there we go. Attendance list. School difference with attendance. Okay, let's try this one. Let's see what do we get. Tammy. So Bobby is attending. Tammy must be missing here. I don't see her. Jamie, Sally, and Danny. Tammy is missing. And that's it. I find the difference. I found the difference, and that's basically it, I guess. It seems like it doesn't really matter that attendance list is actually a list. It's not a set. So I guess that this method works on collections like lists, and I wonder if with dictionaries. I don't think so. Lists and sets are pretty much very similar. And tuples, maybe. Tuples. I wonder if I can do this with a tuple. Let's try it out. I'm curious now. I'm curious, George. Let's see. Tammy, it works with tuples too, so okay. Thank you very much. I wonder if I'm supposed to upload this as an answer here. Like this, maybe? No. Maybe like this? There we go. It's in a single line. That's not okay. I guess this should work. I wonder what the actual answer was. Solution: notice how we don't have to convert the attendance list to a set. Yeah, I actually figured that one out. It does it for you. Print. Well, he does it with an actual print. My refactor hamster keeps working on all the time. School, difference, attendance. Yeah, pretty much the same. I don't need to convert anything. I guess this is going to work with tuples, with lists, and with sets, because they do have that structure. But anyway, okay, it's 11 o'clock already. I've been here for 46 minutes already. Thank you for coming in, and I'm going to continue tomorrow with Python Basics 2. I wonder how... This is another big one, actually. Yeah, it's very big. I cannot even scroll down. Wow, okay. That's a lot. So tomorrow, I'm going to be working on, how it's called, Python Basics 2. Thank you for coming in, and see you later. Oh.